Hi everyone, welcome back to 9th Standard Maths class. In this video, we are going to learn a new chapter, chapter 12, Proportion. This chapter is based on the chapter Ratio that we have learned in 8th Standard. Okay, Ratio chapter we have already learned. What do you mean by ratio? In detail we have learned. Ratio means to make each and everything there will be a ratio. Okay, according to the ratio we can make anything. For example, to make a lemon juice. Okay, for example, to make lemon juice, the lemon, then water, then sugar, everything must be in a fixed quantity. Okay, lemon, water, then sugar, these three must be in a fixed quantity. If one is more and one is less, that compound, that liquid will be not good. Okay, that means there must be a particular ratio. For example, if 1 teaspoon lemon we are using for 1 glass water, then sugar is for 2 teaspoon or 1 teaspoon, then the ratio will be 1 is to 1 is to 2. This will be the ratio. This is just an example. Okay, 1 is to 1 is to 2. If instead of if we are taking 1 glass water and if we are taking 2 teaspoon of lemon, so the ratio will be 2 is to 1 is to 2, then that lemon juice won't be good, because here one quantity we are taking as double instead of 1. Okay, so if we know the exact ratio or exact quantity of a particular thing, we can create what the double quantity. For example, if you want to create or make 2 glass of lemon juice, then here it will be what water will be 2. If water is 2, the sugar will be what? Sugar will be 4 teaspoon. For 1 glass water, 2 teaspoon we are using. So 2 glass water means 4 teaspoon. And the lemon will be what? It will be also 2 teaspoon. Okay. So if we know the basic ratio, we can create by taking double or triple value, we can create whatever quantity. Okay. So that is a ratio. Now here we are going to learn about proportion. Okay. So here proportion means equality in ratio. Okay, equality in ratio is called proportion. What do you mean by equality in ratio? Let's consider an example. Here a small rectangle, the length and breadth is 1 and 2. Okay, length is 2, breadth is 1. So here ratio will be what? 2 is to 1. Length and breadth in the ratio 2 is to 1. If we have another rectangle, okay, if we have another rectangle with length as 4 and breadth as 2, what will be the ratio of length and breadth here? It will be 4 is to 2. Length and breadth, length 4, breadth 2, 4 is to 2. What is the simplified form of 4 is to 2? Both are multiples of 2 that we can cancel with 2. In 4, 2 2s are there. In 2 only 1 2s are there. So here 2 is to 1, here also 2 is to 1 ratio. Suppose we have another rectangle like this. Here it is 6, then 4. Okay, length is 6 centimeter, breadth is 4 centimeter. So ratio will be 6 is to 4. Here also we can convert this. So here we have to take 8. Okay, suppose length is 8 and breadth is 4. So the equation becomes, ratio becomes 8 is to 4. Then what is the simplified form of 8 is to 4? Both are multiples of 4. In 8, total 2 4s are there. In 4 only 1 4. So again we got the ratio 2 is to 1. Here 2 is to 1. Here also 2 is to 1. This means that these three rectangles, okay, these three rectangles, length and breadth are proportional. Okay, length and breadth are proportional. That means because ratios of length and breadth are equal for all these rectangles. Measurement wise everything is different. Measurement 2 here, 4 here, 8 here. But after writing the ratio, everything is the same. 2 is to 1, 2 is to 1, 2 is to 1. So since the ratios are same, we can say that length and breadth of these three rectangles are in proportion. This is known as proportion. Okay, equality in ratio. Ratios must be same. That is proportion. I think you understood. Okay, so let's move on to problems from the first activity. Here is your first question. First question is, a person invests 10,000 rupees and 50,000 rupees in two different schemes. After 1 year, he got 900 rupees as interest for the first amount and 1200 rupees as interest for the second amount. First sub question, are the interest proportional to the investment? Second sub question, what is the ratio of the interest to the amount invested in the first scheme? What about the second? Third sub question, what is the annual rate of interest in the first scheme and in the second scheme? Here in this question, a person invested 10,000 rupees, then 15,000 rupees. Okay, 10,000 rupees and 15,000 rupees in different schemes. These are the amounts. Now interest. Okay, interest he got from the first scheme, he got interest as 900. Then from the second scheme, he got interest as 1200. Now our first sub question is, what is the ratio of amount invested? Okay, ratio of amount. Okay, ratio of amount invested. So ratio of amount invested means, what is the ratio? How can we write the ratio? By writing is to. So first amount is this, second amount is this. So we can write the ratio as 10,000 is to 15,000. Here 3 zeros common, so that 3 zeros we can cancel. So answer is 10 is to 15. This we can simplify once more. That means both are multiples of 5. In 10, how many 5s are there? In 10, so total 2 5s are there. In 15, how many 5s? 3 5s are there. 2 is to 3. That means the ratio of amount invested is 2 is to 3. This is first sub question answer. Now, next is, what is the ratio of interest? Ratio of interest he got. So interest means two interests are what? 900 and 1200. So we can write it as 900 is to 1200. Here also 2 zeros we can cancel. Now 9 and 12 both are multiples of 3. So in 9, 3 3s are there. In 12, 4 3s are there. So 3 is to 4 is the ratio of interest. Okay. Now question is, are interest proportional to amount invested? Are interest and amount proportional? Is it proportional? No, because interest ratio is 3 is to 4 and amount ratio is 2 is to 3. Both are different. Okay, ratios are different. That means they are not proportional. If ratios are same, we can say that they are what? Proportional. But here ratios different, so interest and amount are not in proportion. Okay, this is first sub question answer. Second sub question is, what is the ratio of amount and interest in first scheme? Okay, amount and interest in first scheme. So in first scheme, amount and interest means amount is to interest. That is a way of writing. So amount in first scheme is 10,000. So 10,000 is to interest in first scheme is 900. So 10,000 is to 900. 2 zeros here, 2 zeros here common, that we can cancel. So answer becomes 100 is to 9. Here no need to simplify, keep it like this, because for the third sub question we need this. 100 is to 9 means for each and every 100 rupees, 9 rupees is the interest. Okay, 9 rupees is the interest for 100 rupees. Now second is what? Ratio of amount and interest in second scheme. So in second scheme, amount is what? 15,000. So 15,000 is to interest is 1,200. Here also 2 0 we can cancel. So 150 is to 12. This means for 150 rupees, 12 is the interest. We have to convert this in terms of 100. For that, first let's simplify with 3. So here in 15, how many 3's will be there? 5 3's are 15. 1 0 equal is to, in 12 how many 3's are there? 4 3's are there. So 50 is to 4. Now to convert this into 100, 50 into what is 100? 50 into 2 is 100. So 50 into 2 100 is to 4 into 2 is 8. That means for 100 rupees, 8 rupees is the interest. I did this because for the third sub question we have to write the rate of interest, because third sub question is what is the rate of interest for the first scheme and rate of interest for the second scheme, or percentage. Rate of interest is the third sub question. So rate of interest we always write in terms of 100 rupees. For each and every 100 rupees, what is the rate of interest? So that is the way. So here for 100 rupees, 9 rupees is the interest, means rate of interest will be this 9%. So for the first scheme, 9% is the rate of interest. So for the second scheme, for 100 rupees, 8 rupees is the interest. That means this 8% is the rate of interest for the second scheme. Okay, this is third sub question answer. So first question over. Now let's do third question. Here is your question. Next question number 3. In calcium carbonate, the masses of calcium, carbon and oxygen are in the ratio 10:3:12. When 150 grams of a compound was analyzed, it was found to contain 60 grams of calcium, 20 grams of carbon and 70 grams of oxygen. Is it calcium carbonate? In this question it is about calcium carbonate. In chemistry you have learned about calcium carbonate. Okay, so in calcium carbonate, calcium is there, carbon is there and oxygen is there. These three must be in a fixed quantity, then only that compound will be a calcium carbonate. The original ratio, that means the original quantity of these three, calcium, carbon and oxygen in calcium carbonate is 10:3:12. This is the ratio. That means calcium must be 10, then carbon must be 3, then oxygen must be 12. If one of this quantity is more or less, that compound won't be calcium carbonate. Okay, that is the rule. Now in our question it is given that 150 gram, okay, 150 gram of compound analyzed, 150 gram of the compound when analyzed, we get the amount of calcium, carbon and oxygen. First one, calcium we got as 60, okay, 60 gram calcium we got. Then we got carbon as what, 20 gram carbon. Then oxygen quantity analyzed is 70 gram. Okay, so total 150 gram of a particular compound. We don't know whether it is a calcium carbonate, just a compound we analyzed. When we analyzed this compound, we got calcium's quantity as 60 gram, carbon's quantity as 20 gram and oxygen quantity as 70 gram. Question is it calcium carbonate? That is the question. So if it is a calcium carbonate, the ratio of these three must be 10:3:12. Okay, because that is the original ratio. So these three's ratio must be this one. Then we can say that this analyzed compound is calcium carbonate, otherwise it is not calcium carbonate. So first of all, let's write the ratio. Here the ratio of this 150 gram compound will be 60:20:70. Zeros we can cancel. Okay, so ratio becomes 6:2:7. Is it equal to this ratio? No, it is not equal. So not equal means what? The analyzed 150 gram compound is not calcium carbonate. Okay, this 150 gram analyzed compound is not calcium carbonate. That is the answer for the third question. Okay, now let's move on to next subheading. Next subheading is constancy in proportionality. Okay, constant of proportionality. That means the fixed number occurring in the equation of proportional change. Fixed number. That fixed number is known as constant. Okay, fixed number occurring in the equation of proportional change, that is known as constant of proportionality. Okay, and that is denoted by K. We'll explain more. For example, a square. Consider a square. If side of the square is x, its perimeter will be what? Perimeter. What is the equation to find perimeter of a square? 4 sides equal. Equation is 4 into side, that is 4x. Okay, so here perimeter we can write as what? Y. Okay, perimeter we can consider as y. So y equal to 4x. Question is perimeter and side of the square in proportion? Then what is proportional? Constant. So here perimeter and side is it in proportion? Proportion means if one quantity increases, according to that the next quantity must increases. Okay, that means ratios must be same. So here perimeter 4 into x. Suppose the side is 1. Suppose the side is 1. Answer becomes what? Perimeter equal to 4. 4 into 1. 4 will be the answer. If perimeter is, side is 2, what will be the answer? It is 4 into 2. Here 4 into 1. 4 into 2 will be the answer. Okay, y equal to 4 into 1. Here perimeter y equal to 4 into 2. Suppose it is 3. Answer becomes what? 4 into 3. That means when the length of side increases, that perimeter is increasing with 4. Okay, that means this 4 is a fixed quantity here in this equation. Okay, these two are in proportion. That means when we divide this perimeter y with x, we must get a fixed quantity. We must get a fixed quantity. We will get the exact answer, because what is perimeter here? Y is the perimeter, because we are considering the proportional for perimeter and side. Okay, we are considering with perimeter and side. If we are considering perimeter and side, perimeter must be y and side must be x, and this y by x must be a fixed quantity. Let's check. Equation is what? Y equal to 4x is the equation. So if we take this x to this side, y by x is equal to 4 is the answer. So here we have a fixed quantity 4. So perimeter and side of a square are in proportion, and the constant of proportionality is 4 here. You got constant of proportionality means the fixed number. This number is not changing. Whatever be the number of side, this 4 is a fixed one. That's why 4 is the constant of proportionality. Okay, so this is the definition for proportionality constant. Now let's move on to problems from the second activity, page number 185. Here is your first question. First question is, for each pair of quantities given below, check whether the first is proportional to the second. For proportional quantities, calculate the constant of proportionality. Total 5 sub-questions are there. Let's do one by one. In the first question, we have to prove that in each statement, two quantities are given. We have to check whether the given two quantities are in proportion, and if it is in proportion, what is the constant of proportionality? That is the question. Our first sub question is perimeter and radius of circle. So we have to prove that perimeter and radius, whether perimeter and radius are in proportion or not. So what is the equation here? Perimeter equation, perimeter of circle equation we have learned in the chapter prism. So perimeter equal to circles chapter we have learned. Perimeter of circle equation is 2 pi r. This is the equation. Now I told you, if perimeter and radius means perimeter we have to consider as y and radius we have to consider as x. So 2 pi into x, and we must get what? This y by x must be a fixed number. Then we can say that these two are in proportion. So here perimeter y, take this x to this side. So y by x, answer becomes what? 2 pi. 2 pi is a fixed value, because pi value is a fixed number, 3.14. So this perimeter and radius of circle are in proportion. Okay, are in proportion. And what is the constant of proportionality here? Proportional constant k equal to 2 pi. Okay, proportional constant is k equal to 2 pi is the constant of proportionality. This is first sub question answer. Now let's do second sub question. Second sub question is area and radius of circle. So we have to prove whether area and radius of circle are in proportion. So what is the equation? Area of circle. Area of circle equation is pi r square. Okay, pi r square is the equation. Now we have to choose area as y and radius as x. So pi radius square here. So x square. We are considering only radius. So x square. Now what we must get y by x we have to. So y by here x square means it is what? Pi into x. Okay, so only one x we can take here. So y by x answer becomes pi into x. Is it in proportion? No, it is not in proportion, because y by x we must get a fixed number here. It is not fixed number, because as x changes here the value will be different. For example, if radius is 1 centimeter, here the answer becomes what? Y by 1 equal to pi into 1. Okay. Now if radius is 2 centimeter, here answer becomes y by 2 equal to 2 pi. That means here the value is different. Pi comes, then next it will be 2 pi, then 3 pi, like that it will move on. So it is not in proportion. We must get here a fixed number. As it is not a fixed number, area and radius are not in proportion. So not in proportion means there won't be what? Constant of proportionality also not there. Okay, no k here, no fixed number here, because they are not in proportion. But area and square of radius will be proportional. Can you say why? Area and square of radius. Suppose question is area and square of radius. Square of radius means square of radius we can consider as x. That means this r square we can consider as x. So r square x means it will be pi x. So here becomes pi. Okay, y by x equal to pi we will get. That means area and square of radius in proportion, but area and radius not in proportion. That is the difference. Okay, so this is second sub question answer. Now let's do next one. Third sub question is the distance traveled and number of rotations of a circular ring along a line. Okay, that means if a circular ring, if we move in a rotate in a circular line, the number of rotations. Okay, the number of rotations and distance traveled, relation between distance traveled and number of rotation. So if ring rotate only once, okay, if a ring, okay, for example, if a ring rotate only once, circular ring. So circular ring means rotate to one means it cover that perimeter. Okay, if we rotate a ring means ring means it is a circular ring. Okay, a circular ring. If we rotate this means what? Like this. Okay, if we rotate once means it will cover the perimeter. Okay, it will cover the perimeter of this ring. Okay, perimeter of this ring will cover if rotate once. So distance will be what? Distance covered means perimeter will be the distance. So distance in one rotation. Distance in one rotation. If ring rotate only once, the distance covered will be 1 into 2 pi r. Okay, 1 into 2 pi r will be the distance. So here distance we can consider as y, and this covering rotation and distance. So rotation we can consider as x. So here this is x. So one rotation means x. Now if distance covered in two rotate, okay, if distance in two rotation means what? Two rotation means 2 times we have to find the perimeter. 2 into 2 pi r. Okay, so similarly distance in x rotation, because we are considering rotation as x. So x rotation means equation becomes x into 2 pi r. X times 2 pi r we have to find. So distance y, rotation x, so y by x answer becomes 2 pi r. So is it in proportion? Yes, it is in proportion, because radius of a ring is same here. Okay, because whatever be the rotation we are considering the same ring. So 2 pi r is a fixed value here. That means the distance and the rotation of circular ring is in proportion, and constant of proportionality k equal to 2 pi r. Okay, constant of proportionality is 2 pi r here. Okay, this is third sub question answer. Next is fourth sub question. Fourth sub question is interest and amount. Okay, interest and amount for a compound annually compounding. Okay, annually compounding scheme. What is interest and amount in proportion? So here what is the equation interest and amount? Just interest equation is I equal to P in R. So here annually compounding means number of year it will be 1. So we can write it as I equal to P R. Now interest and amount means interest we can consider as y and amount we can consider as x. So here equation becomes y equal to xr. Okay, that means y by x equal to r. Is it in proportion? It is in proportion because interest divided by amount, we got a fixed answer. That means rate of interest is the constant of proportionality. K equal to R percentage. That means rate of interest is the constant of proportionality here. So interest and amount in a particular scheme is proportion. Okay, these two are in proportion with the constant of proportionality K as R percentage. Okay, so this is fourth one answer. Now let's do fifth one. Fifth one is volume of water in a hollow prism and height of the water level. So volume and height are in proportion in a prism. That is the question. So what is the equation? Volume of any prism that we have learned, volume equal to base area into height. This is the equation we have learned to find the volume of any prism. In prism chapter we have learned this. So volume equal to base area into height. So here we have to consider the two quantities, volume and height. So if we consider volume first, volume we can consider as y and height we can consider as x. So base area into height is x. So y by x equal to base area. Is it in proportion? It is in proportion because y by x we got the answer as what? Base area. Base area is the constant of proportionality. K equal to base area. Base area of the prism will be fixed 1. Okay, whatever be the shape of prism, that base area will be fixed 1. Only volume and height will change. According to the height increases, the volume will increase. No need to consider base area. So base area is a fixed quantity, that is constant of proportionality. K is base area, volume and height in any prism are in proportion. Okay, so this is fifth one answer. Now let's do question number 2. Here is your question. Question number 2. During rainfall, the volume of water falling in each square meter may be considered equal. First sub question. Prove that the volume of water falling in a region is proportional to the area of that region. Second sub question. Explain why the height of rainwater collected in different sized hollow prism kept near one another are equal. Here in this question it is given that during rainfall, if we consider a particular area, the quantity of water falling in each square meter, that means each and every area we can divide into 1 square meter. Okay, all are 1 square meter we can consider like this. Okay, now in each 1 square, that means here the water fall in this one and in one here, everything will be equal. That is already given. We have to prove that the volume of water in the whole region, okay, volume of water falling in this region is proportional to area of that region. Okay, volume in a whole region is proportional to area of region. This is what we need to prove. So for that, let's consider volume of water in 1 square meter. We know it is fixed. Okay, in each and every portion it is fixed. Let's consider that fixed quantity as K. So volume of water in 1 square meter. Okay, in 1 square meter, in 1 meter square it is K. Let's consider like this. Here K, here in K, here K, like that. Now in 1 meter square it is K, means volume of water in 2 meters square will be what? Answer becomes 2 into K. For example, if in this region, if 1 liter water is there, then in this 2 meters square volume of water will be 2 liter, isn't it? That means 2 into K. Now if it is for 3 meters square, okay, if 3 meters square if we are considering, then volume of water will be 3 into K. Like that it will continue. Suppose the area of this region, suppose total, how many portions? Total x portion. Suppose here x meter square is the portion, then volume of water becomes what? X into K. Okay, if area of this region is x meter square, then volume of water will be x into K. So volume of water we can consider as y. Okay, that is y in x meter square. So here y by x is equal to K. That means these two are in proportion. Volume of water in region and area of that region will be in proportion, and constant of proportionality is that K. In 1 meter square, what is the answer? That will be the fixed quantity K. Okay, this is second question answer. One more sub question is there. Try to do that as homework. Now third question. Question number 3. When a weight is suspended by a spring, the extension is proportional to the weight. Explain how this can be used to mark weight on a spring balance. Okay, check the figure properly. In this question, spring balance. It is about spring balance. You know what is spring balance? It is to measure the weight. Okay. Now here in this spring balance, it is given that the weight and extension of the spring, okay, the weight and extension of the spring is proportional. That is already given. How we can use this to measure the weight? That is the question. Now here, suppose if we are suspending 100 gram here, suppose we are placing 100 gram weight, extension suppose it is x centimeter. Okay, extension is x centimeter. Now again, if we are placing a 200 gram, okay, suppose we are placing a 200 gram, what will be the extension? It will be more. Okay, extension, that spring will be extend more. That answer will be what? For the first one, extension is x centimeter. If 100 gram is weight, extension is x centimeter. Suppose 200 gram is the weight, then extension will be what? Double. Here x means here it will be 2x times 2 times the distance will be. Suppose this is 5 centimeter, then if we are placing 200 gram, it will be double. 2 into 5, 10 centimeter. So for the second case, if weight is 200 gram, extension will be 2 into x. Similarly, if weight is 300 gram, this spring will be extend little bit more. Okay, so extension will be 3 into x. Like this it will move. By marking this, we can find the what? Measurement. For example, if we are placing a particular weight, we don't know what is that weight. The spring balance extend 10x centimeter. Okay, if the spring 10x centimeter, then what will be the weight we have placed here? Okay, what will be the weight we have placed here? Weight of this one. Okay, if 1x means it is 100 gram, if 2x is 200 gram, 3x means 300 gram, so 10x means what? 1000 gram. That is 1 kg will be the weight. Okay, by marking the distance or extension, we can find the weight of that particular thing. Okay, no more steps to write here. Just by your own words you can write the answer. Okay, so this is third one answer. So let's stop here. Let's continue the class in next video. One more section is there that let's include in the next video. So hope you understand. Thank you. See you in the next video.